So let's talk about hexokinase and glucokinase. And here we're going to talk about mostly Km value and vmax value, right? So let's start the topic. So we have two things. We have a Km value and we have a vmax, right? A lot of people try to memorize this, but honestly, you don't have to memorize it at all. How to understand this concept is just simply listening to me. So, imagine that you are the cell, okay? Imagine that. Just close your eyes, and then now you have an enzyme, right? Now, what is this enzyme trying to do? Right? What's the function of this enzyme? This enzyme's function here is that it wants to change the substrate. That's the glucose in our case, and change it to the product. What's the product in our case? In our case, the product is glucose 6 phosphate. That's the product, right? We are talking about hexokinase and glucokinase right now. So for glucokinase, hexokinase, this is the substrate and the product is glucose 6 phosphate. Now, what is an enzyme? Enzyme is just a machine, right? It's a biological machine that gets used up. I mean, that doesn't get used up. That actually you push some raw materials inside and you get some finished products out, right? So that's biological machine. That's an enzyme, right? So can an enzyme work without glucose, without substrate? Absolutely no. Enzyme needs it, right? Enzyme needs the substrate. Substrate means the molecule that enzyme acts upon, right? So my enzyme is maybe enzyme. That's my enzyme right there. And it's going to act upon the substrate to change that, right? You need to have the substrate. Enzyme can only fail if we don't have enough substrate, right? So our substrate here is glucose. Our enzyme here is maybe glucokinase or hexokinase, right? Now let's imagine a little bit different things, right? Now let's do a little test, right? So we have experiment number 1, right? This is experiment number 1. What's the experiment number 1? This is a test tube. Okay? This is a test tube. In this test tube, we have very little glucose. This is a particle of 1 molecule of glucose, and we have 1 molecule of enzyme. Now, the question is, can the enzyme work rapidly? I don't think so, because we don't have much glucose, right? That's the glucose right there. But we don't have much of it, right? So enzyme is waiting, right? So the question here is enzyme will work rapidly or not? No, it's not gonna, because we don't have enough enzyme, enough glucose. On experiment number 2, let's make another again test tube, right? So that's my test tube right there. Okay, looks a little not like test tube. Now this looks like a test tube, right? Now we have more glucose, maybe like 50 particles. Okay, it's like 50 of them. Now I'm not gonna make 50, but yeah. And that's my enzyme. Okay, so my enzyme is this, my glucose is these particles, right? How about this time? Now the glucose will bump into enzyme much more often, right? So the reaction speed will increase. So speed here will go up in experiment number 2. In experiment number 3, again, I'm gonna make another test tube. This is gonna be my test tube. Looks cool as hell, right? Wait, let me make it again. Yeah, okay. 3 times. Yeah, okay, never mind. Now I'm gonna put a huge amount of glucose, right? Okay, let me put it here. Now I'm gonna put a lot of glucose here. Now I am putting like 200 molecules of glucose. Now that's the glucose. That's my enzyme right there, right? So if that's my enzyme and that's my glucose, now the question is, will the enzyme become infinitely fast? That's the question. Will the speed go to infinity? Like infinitely fast? Will it? I don't think so, right? Because of a thing called saturation, right? Why? Because of saturation. The enzymes, saturation, right? Now, the enzyme is gonna get saturated, right? Now, what is saturation? Saturation is this, for example, one cashier can only accept one customer. That's great. Now we have 100 customers. Now the cashier cannot suddenly just become 100 times faster, right? Eventually, the cashier is gonna work as fast as he physically or she physically can, right? But the enzyme, but the saturation gonna hit up this cashier. So that's the concept of saturation. Okay, this right, this enzyme behaves exactly in the same way. This maximum speed has a name, right? This maximum saturation, this speed, right, has a name. What is it called? It's called vmax. Okay, so the concept here that I'm trying to push is vmax. Vmax. Now, what am I saying? V is the velocity. V is the velocity here. Max is the maximum, right? So velocity max. What is Vmax? So Vmax is the fastest rate at which the enzyme can work. Now, at which enzyme can work when every enzyme molecule is occupied by the substrate, right? When enzyme is saturated, or I should say, in other words, right? So at maximum speed, what's the maximum speed of the enzyme? When the enzyme is saturated, right? Now, I'm not here asking about fastest enzyme. Instead, I'm asking fastest, or I'm asking fastest possible reaction rate here, Vmax. Okay, now can the Vmax become larger by simply adding more substrate, right? Can I increase the Vmax by increasing substrate? I don't think so, because once the enzyme is like saturated, adding more glucose or substrate is not gonna help it, right? Because just imagine you have one cashier, right? Imagine adding like 10,000 customers to one cashier, to one register. You just still have one cashier. Maybe, for example, this cashier can deal up to 2 customers per minute, right? Doesn't matter if you have 2,000 customers or 200, right? The speed, the Vmax of this cashier is going to be 2 customers per minute. So that's the concept of Vmax, okay? Then the question arises, how can I increase the Vmax? How can I increase the Vmax? So let's increase the Vmax. How will I do it? We can increase the Vmax by increasing the number of what? Enzymes, right? So Vmax, how do we increase the Vmax? One of the ways, let's just increase the amount of, right, number of enzyme. Let's just increase that, because that'll solve our problem, right? One enzyme, slow Vmax. 100 enzymes, much larger Vmax, right? So this is important for insulin, right? I'll come back to it. So this is important for insulin. I'm gonna join you to this concept. Wait. Okay. So that is Vmax, right? Let's talk about Km. So Vmax, we are done with you. Not done, we understand you now, right? We understand you better. What about Km value? Let's understand Km value. So Km value, how should I explain it? Km value is asking basically how easily does an enzyme grabs its substrate? How easily does this enzyme wants this substrate? How much it wants? Now we call this want, right, as something which is called as affinity. We call it affinity, right? Now this property is called affinity, right? Now what is affinity? Affinity is how strongly an enzyme how strongly an enzyme binds to its substrate. For example, we have a strong magnet. It immediately grabs the metal, right? But when we have a weak magnet, it needs to get much closer to the metal. So enzymes are similar. So that's the affinity. That's Km value. How much the enzyme loves the substrate, right? So how are we gonna measure it, right? So the thing is, Km value measures affinity, right? The definition is that Km is the substrate concentration, right? I'm writing it. What is Km? Km is substrate concentration at which the reaction reaches 1/2 of vmax, right? This definition is very nice, I think. Now the problem is that a lot of people don't really, they don't build any intuition about it, right? To build some sort of intuition, let's take an example of a dog, right? We have two dogs. We have dog A and we have dog B. Now, the moment you throw food, dog A goes and just bites on it, right? Bites on it. And the moment you throw the food at dog B, the dog B ignores the first pieces and only runs when the food appears, right? Only runs when the food appears in a big amount. Or I can say it only runs when lots of food appears, right? So my question here is, which dog has higher affinity for the food? Of course, dog A, because dog A bites even at very little amount, right? So what I'm trying to say is that what low Km value is, right? Low Km value means only a tiny amount of glucose is needed before the enzyme even starts working, right? So a tiny amount is enough for the enzyme to start working. Therefore, low Km value equals to high affinity. I hope it makes sense, right? And high Km value equals to low affinity, right? High Km means the enzyme really ignores the glucose, right, or the substrate, and only when the glucose becomes really abundant it starts working. Therefore, high Km means low affinity, right? Okay, so we don't want to memorize that low Km, high, right? We don't want to memorize that, right? We want to reason it. Okay, so let's put hexokinase in the picture now. Now, hexokinase, right? It's an enzyme found everywhere, right? But not in liver and not in pancreatic beta cells, right? And the thing is that hexokinase has high affinity, right, towards glucose. It goes and sucks up every glucose, every little particle of the glucose, right? Great for little meal that you have, right? Now, let's think. So question is that blood glucose, right? Let's think about hexokinase, right? We apply the physiology. And the question is, when you don't eat for the whole night, what happens to your blood glucose? The blood glucose falls overnight, right? Now, should the brain cell stop using the glucose whole night? Absolutely not. Hexokinase must work, right? So question is that you slept, you had a huge fast, right? Your blood sugar went down. Blood BS, no. Blood glucose went down, right? What happened to your brain? Nothing. Why? Because hexokinase was working. So even when the blood sugar was low, what kind of cam should that require? A low cam, right? Why? Because low cam means high affinity, right? Low cam is just substrate concentration at which the reaction reaches half of Vmax, okay? So that's the thing, right? So hexokinase, right? Hexokinase must work even when the blood sugar is low because hexokinase has high affinity, and that's how your brain is still alive when you're sleeping. What about glucokinase? Well, now liver. Question. Suppose the blood sugar is like, let's see. Right now your blood sugar is 70 milligram per deciliter. Right? Now, should the liver aggressively remove the liver? Should the liver aggressively remove the glucose from your blood? What do you think? Of course not, because your brain, RBCs, and muscles need it, right? Therefore, glucokinase purposely waits. Now, the question is, how? How can it wait? I mean, it doesn't have a brain of its own, right? It waits because glucokinase has a high Km value and a low affinity. That's why glucokinase ignores the low sugar. Only when the glucose is high enough, only when the glucose is abundant after big meals, the glucokinase becomes very active. Now, why this is amazing? Because imagine liver had hexokinase. Immediately after when you had some big meal, immediately after glucose enters the blood, the liver would remove all the particle of blood, and brain might temporarily receive less glucose, right? But the evolution was like, not gonna let it happen. So that's what happened, right? The glucokinase says that I'll wait until everyone has enough glucose, right? Now let's talk about Vmax. Suppose you eat, right? You just had a huge plate of rice. Now blood sugar shoots up. Now what? Should the liver remove the blood sugar? Right? Should it do it? 1 glucose molecule per second. Should the glucose remove the high blood sugar? Of course not. It must remove the blood sugar fast, right? Not slowly, because this insanely high blood sugar can be dangerous for us, right? So it must remove the glucose rapidly. Therefore, glucokinase has high Vmax, meaning it can process the glucose on a higher capacity, right? So in other words, I can say that, what can I say? I can say that, other words, Vmax equals to high capacity to handle what? To handle substrate. Right? So Vmax means huge processing capacity, right? Now, why doesn't the hexokinase have high Vmax? Why do you think so? Because brain doesn't normally need to clear these massive glucose loads that you get after eating, McDonald's, right? So it only gets enough glucose, right? And to meet its own demands, therefore the Vmax is sufficient for the hexokinase, right? And now let's come back to the hexokinase and glucokinase, right? So the topic here is that hexokinase needs to work fast, right? Mr. Hexo needs to work fast. That's first point, right? Second point is it needs to work even when you're fasting, right? So fasting, and doesn't need huge capacity. No huge capacity needed, because it doesn't need to clear the higher amount of blood sugar, right? Therefore, Mr. Hexokinase is gonna have low Km value, first of all. That's first thing. Because it has a lower Km value, Mr. Hexokinase is gonna have high affinity. Gonna love to suck up that glucose. Now, because it has higher affinity, what is going to have a low Vmax? Low Vmax, right? It's going to have a low Vmax. Vmax is just the capacity, right? I mean, if you have higher affinity, you can't have higher capacity, right? It's kind of natural to think about. Now, what about glucokinase? Well, glucokinase, on the other hand, Mr. Glucokinase needs, right, to wait and then after the meal remove huge amount of glucose. Therefore, Mr. Glucokinase needs to have first high Km value, and then because it has a high Km value, it will have lower affinity for glucose. That's how it'll wait, right? And because it has a lower affinity, it can handle huge amount of glucose. That's we called high Vmax, right? So that's our high Vmax right there. Okay. Wow, looks so pretty. So glucokinase has high Km and hexokinase has low Km. I think that's enough to remember. If you just remember that hexokinase has low Km and glucokinase has high Km, you can just basically derive everything, right? Now let's think about patient. Patient comes to you. Patient is fasting overnight. Blood sugar is like 65. Which enzyme is still working? What do you think? Of course, hexokinase, because it needs to push that glucose inside the brain, yeah? And what about the Km value? It's going to be high or low? It's going to be low, right? Why? What is Km value? Km value is just affinity, right? Okay, what about second patient? Patient comes to you, birthday cake, blood sugar is like 190 through the roof. Which enzyme is working super actively? Of course, glucokinase. Why? Because high glucose is exceeding, right? And we need to remove that. So glucokinase is gonna work, right? Now, when would this system break? Suppose glucokinase has a low Km value. Let's just imagine. Instead of high Km value, glucokinase has low Km value. What happens now? Liver will think, so much glucose. Let's just remove the glucose. Oh, wait, we're still fasting. No, I'm still gonna remove the glucose because my Km is low and I love glucose. So it's gonna gulp this whole glucose, and your brain is gonna compete with liver actually, and liver will become a competitor rather than a buffer for sugar. So that's very bad design. And same thing would kind of happen with hexokinase. Imagine hexokinase had a higher Km. Now you need to eat so much food just to feel alive. That's kind of what happens in diabetes type 1, right? Brain during fasting, blood sugar is like 70. Hexokinase is not working because hexokinase supposedly have higher Km value. So brain ATP falls. So you'll be like, oh my God, I can't even think. Now imagine if glucokinase has Vmax, right? It has a low Vmax. It cannot handle large amounts. Now imagine you had a big meal. Blood sugar is rising. Now liver just will not process the glucose quickly. You will have hyperglycemia for prolonged time, and you will have problems because of that hyperglycemia, right? So if a question says that high affinity for glucose, we want to think hexokinase, right? Why? We want to think hexokinase, and we want to think low Km immediately. If it says that functions even at the low glucose concentration, we want to think hexokinase, right? If someone says it processes large amount of glucose after meal, we want to think glucokinase, because glucokinase can work at larger capacity, and we want to think about high Vmax, right? So that's basically the whole concept about Vmax and Km value. Km value is inversely related to enzyme affinity. That's the whole, I should say, summary of this whole Km, not Km, right? Let me write it. Km value is proportional inversely to what? To enzyme affinity. So affinity means if affinity goes up, Km value goes down. That's point number one. Point number two here is that low Km means high affinity, right? And enzymes works well, right? For example, Mr. HEXOKINASE, right? What about Vmax? Vmax is just the maximum reaction rate achieved when all the enzyme molecules are saturated with the substrate, right? HEXOKINASE has low Km, right? GLUCOKINASE has high Km, right? So because affinity and Km go inverse, just know that. So the concept is simply that's it, right? Km value and Vmax value are not arbitrary, like they are like cool. We are just trying to understand these enzymes. That's it. It's nothing so, I don't know, complex, right? So I hope you understood that and you don't need to memorize a lot of stuff for it. Take care.